So in this session, we will discuss the topic wise questions related to rate and order of the reaction. You can also participate and state the answer which you think could be the right one. Which of the following graphs shows the reaction of first order with respect to reactant X? X is a reactant, and when there's a bracket, it means it is showing the concentration. Which one is a first order reaction? A, B, C, or D?
It should be C.
Yeah, it is C. Because concentration and time variation, the concentration of the reactant is decreasing, and when we work out the half-life, estimate the half-life, we'll find that it is approximately same. A is for zero order reaction. Even the concentration and rate graph, there is no change in rate when the concentration is changing. That is also for zero order reaction. And here rate and concentration, if we double the concentration, rate is increasing with a greater rate, so it means it is a second order reaction. So C is the right answer. Methods of investigating the reaction rates are included. Colorimeter, like we can work out the color change. So for this technique, one of the substance, either a reactant or product, should be colored. We can measure the change in volume. That can be done if there is a gaseous change in both of the gas or a gaseous product is there. We can change the change in mass. We can also use the change in mass to measure the rate of reaction. That can also be used for if a reaction involves a gas is given off, and then quenching followed by titration with acid. So if alkali is involved as a reactant, so we can titrate with acid. These are some techniques which can be used. So in part A, they're asking which method would be the most suitable to investigate the rate of the following reaction.
Probably D.
D. Why? Because when you see the reactant, there's an alkali involved. If there's an alkali, it means we can quench, take out the sample and then quench so that the concentration of the reactant does not change, and then we can react with an acid. That's right. So this was part A. Then part B, we have unsaturated hydrocarbon reacting with hydrogen iodide to give CH3 bracket 3Cl. So if there is a change in amount or moles of a gas, so which technique we can use, A, B, C, or D?
Change of mass.
Change in volume, because change in mass is there when a gas escape, but here what happened, the number of the moles of the gas are changing. In the beginning you have 2 moles of a gas, but as a product is formed you have 1 mole of a gas. So when number of the moles of a gas will change, because why the change in mass is not a suitable technique, as all of them are in the gaseous state. So if you have a container or a flask or a reaction mixture in a flask and they are in the gaseous state, so they will escape. So all of them will escape. You don't have some content left in the flask. That's why you cannot use change in mass. It should be change in volume. So B will be the right answer. Is it clear?
Yes, sir.
Then BrO3 with a charge -1 reacted with bromide ion in the presence of acid gives bromine. So bromine is there in aqueous state. It is orange in color.
Yeah, so colorimetry.
Calorimeter can be used. That's why A can be a right answer for this. Which of the following changes will lead to a greater increase in rate of the following endothermic reaction? So reaction is endothermic. We know rate is directly proportional to temperature and rate is directly proportional to concentration of the reactant as well. So what could be the right answer for question 3? Rate of the reaction is proportional to temperature and rate of the
So
reaction.
D.
Yeah, that's right. Rate of the reaction is directly proportional to concentration. So if you increase the amount of the reactant, the rate will increase. And if you increase the temperature, the rate will also increase. Even the reaction is exothermic or endothermic, the rate is directly proportional to temperature. In question 4, hydrogen is reacting with nitrogen monoxide to give water and nitrogen. This reaction is first order with respect to hydrogen and it is second order with respect to nitrogen 2 oxide. So if we write the rate expression, we can say rate is equals to concentration first order with respect to hydrogen and it is second order with respect to nitrogen monoxide or nitrogen 2 oxide. By what factor the initial rate increase if the concentration of hydrogen and nitrogen 2 oxide both triple? So if we triple this concentration, because it is first order, so rate will be triple. If we triple this concentration, rate will increase by 9. So what is the total change in the rate? It will be 9 multiplied by 3 or 3 multiplied by 9, which is equals to 27. So rate will increase 27 times. That's why D will be the right answer. Is it clear?
Yes, sir.
Next question. Methods for investigating the reaction rates include calorimeter can be used. If one of the reactant or a product is colored, we can use this technique. Collecting and measuring the volume of a gas, if change in moles of a gas, we can use this technique. Quench and followed by titrating with acid. If alkali is involved, we can use this technique. And quench and followed by titration with iodine. If high sulfate is there, we can use this technique. Which method would be the most suitable to investigate the rate of the following reaction? Hydrogen peroxide reacted with iodide produce iodine molecule. Iodine molecule, if it is high in concentration, it will be brown in aqueous, and if it is low in concentration, it will be yellow. And this is colorless. This is also colorless, colorless, colorless. So which method is the most suitable here?
Colorimetry.
Yes, so A will be the right answer. Then C4H9Br plus OH gives C4H9OH plus Br. So OH is involved. OH is from alkali basically. So which technique we can use?
The acid one.
Yeah, so quench the followed by a titration with acid, and quenching can be done by either changing the temperature or adding a certain reagent which stop the reaction. So that is C. In question 6, for a given initial reactant pressure, the half-life for a first order gaseous reaction was found to be 30 minutes. So half-life is 30 minutes. If the experiment was repeating half the initial reactant pressure, the half-life would be, keep in mind it's a first order.
So 15.
For a first order reaction, the change in concentration with respect to time, that half-life is constant. So even if you use, like example, first we use 100 moles, now we are using 50 moles. So if 100 moles took, say example, 5 seconds or 5 minutes to convert into products, so 50 moles will also take 5 minutes to convert into the product. So half-life for first order reaction is constant, it does not change. That's why B will be the right answer. Is it clear?
Yes, sir.
Question 7. To determine the activation energy, the variation of reaction rate with temperature investigated, the rate constant K is related with. So what we can do, if you plot a graph y is equals to mx plus c, on y-axis if we have ln k, and on x-axis we have 1 over t. So what will be the gradient of the graph? The gradient of the graph will be equal to EA over R. So what could be the right answer? The horizontal and vertical axis.
D.
So D would be the right answer, because on vertical axis if it is ln k, on horizontal axis it is 1 over t. In question 8, in kinetics, the progress of a reaction can be followed by methods which are shown. Calorimeter, again if it's a colored substance. Measuring the optical activity. What is the concept of measuring the optical activity? That because some of the molecules tend to rotate the polarized light clockwise, some of them tend to rotate anti-clockwise. So we can identify there's a change in optical activity. Measure the change in mass. It is possible if the gas is given off. Quench with ice water followed by titration with acid. So we can quench and titrate with acid. So which OH means alkali. So what could be the right answer for question A, part A?
So D.
Yeah, D will be the right, because it's an alkali, so alkali can be quenched with an acid. Then iodine is there reacting with propanol, form hydrogen iodide in aqueous. So which technique is suitable here? A, B, C or D?
Colorimetry again.
Yeah, because iodine is there in aqueous state, uh, which is colored, but there is no product which is other than this is colored, so A will be the right answer. Okay. Then when the reaction occurs, there is a change, there can be a change in optical activity, that the optical activity of a substance might change. We can have two types of substitution reaction, SN1 and SN2. In SN1 and SN2 reaction, it's related to same as AS. Then in SN2 reaction, what happened? So there are two types of reactions in terms of substitution. You can have SN2 reaction and you can have SN1 reaction. What is the difference between SN2 and SN1 reaction? In SN2 reaction, S stands for substitution, N stands for nucleophilic, and 2 is representing that its rate depends on both molecules. Like if you have a primary compound, and this happened for tertiary. What happened in a primary compound? In a primary compound, like if halogen is there, halogen alkane, so this X is representing the halogen. There is one carbon chain represented by R, and then hydrogens are there. Because hydrogen atoms are smaller in size, so if there is an attacking nucleophile, carbon is less electronegative, so it will be partial positive, and halogen alkane is more electronegative, so it will be partial negative. So this attacking nucleophile OH can have space, so it can attack on this positive center, and this carbon will break the bond with halogen. Because the reaction depends on the presence of both OH and the presence of halogen alkane. So when we write the rate expression for SN2 reaction, so rate will be equal to the concentration K times the concentration of nucleophile as well as concentration of halogen alkane, which is in this example it is R, H, H and X. Is it clear this concept that the rate expression for the primary depends on presence of both molecules, that
Yes,
halogen
sir.
alkane should be there as well as the OH group. So greater the concentration of both react molecules, greater the rate of reaction. But in tertiary, what happened? The carbon which is bonded with halogen is having three alkyl groups, three carbon chains. So this carbon is actually surrounded by bigger molecules. So as this carbon is surrounded by bigger molecule, even the OH is present, but this OH cannot attack on this carbon, and we call that as a steric hindrance. So due to steric hindrance, this OH cannot attack on the carbon. So if this OH cannot attack on the carbon, the rate only depends on the presence of halogen alkane. So if we have an expression in which we have only halogen alkane is involved, it means that is SN1 reaction. If we have both halogen alkane and alcohol OH group is also involved, we call that as SN2 reaction. So if we have a table and we have to identify from the table that whether it is SN1 or SN2, so it's a simple way we can identify, because we know that for SN2 the rate of the reaction depends on presence of both molecule, like it depends on the concentration of OH and it also depends on concentration of halogen alkane. So example we have 0.1, 0.1 and the rate was example 2. This we made 0.2, this is 0.1, so rate will be double. And this we kept 0.1, this is 0.2, so rate will also be 4. So it shows when we double the concentration of halogen alkane, rate is double. When we double the concentration of OH, rate is also double. So rate depends on presence of both. So when we write the rate expression, it will be K times the concentration of OH and the concentration of halogen alkane. So that's why we called this as SN2 reaction or nucleophilic substitution reaction, in which both species are responsible for change in rate. But if it was SN1 reaction, so if this was SN1 reaction, then what will happen? That the rate does not depends on both. Like if this is 0.1, this is 0.1, rate is 2. We double the concentration of OH, the rate remains same. But if we double the concentration of halogen alkane, the rate also doubles. So it shows that the rate only depends on the concentration of halogen alkane but does not depend on OH. So it will be SN1 reaction which occur in tertiary compounds. So the next question is actually related to this. So in this question they are saying halogen alkane react with hydroxide ion to form an alcohol. Which of the following statement is true if the reaction is first order? If the reaction is first order, it means SN1. Why SN1? Because when we write the rate equation for SN1 and SN2, so for SN2, we have rate is equals to concentration of OH and concentration of halogen alkane. So it is overall, it is second order, the total. But for SN1, because the rate only depends on the concentration of halogen alkane, so it is overall first order. So what could be the right statement?
So
In
C.
C will be the right statement. Directly reaction mechanism will be SN1. Is it clear?
Yes, sir.
And if you remember the mechanism, reaction mechanism for SN1 and SN2 from AS, that in SN2 reaction, the bond breaking and bond forming will take place at the
So
same time,
intermediate, yeah, will be
intermediate
formed.
form. So when you check the option increasing the concentration of hydroxide ion, though that does not affect because it is SN1 reaction. The rate equation, the rate equation is rate is equals to concentration of halogen alkane. What is a mistake here? Very small mistake. They did not write K here. There should be a K because it's an equation. So when equation is there, we replace with equal to and constant. That's why B is not right. What about D? Involve formation of a transition state. That's also wrong because it's a SN1 reaction in which the bond will break and then the bond will form. So there's no intermediate or a transition state. In question 10, the equation for oxidation of bromide ion to form bromate 5 in acid solution is shown. If the concentration of all three reactant double, how the rate will change? If all three are double, means that is bromate ion is double, bromide ion is double, and hydrogen ion is also double. So due to change in bromate 5 ion, it will be three times, sorry, double. I wrote 3 here. So if we, due to, because first order, so it will be double. Because of bromide ion, it will be double, but it is second order with respect to hydrogen ion. So if hydrogen ion concentration is double, it will increase by 4. So what is the final
So
answer?
16.
So D will be the right answer. Question 11. The gaseous first order reaction A form B and C was found to have the half-life of 20 seconds when initial pressure was 2 atm. When the initial pressure is increased to 4 atm, the half-life is question to
The same. Yeah.
so because it's a first order, so for first order the half-life remains same even we change the concentration. That's why B is the right answer. Question 12. Sulfuryl chloride SO2 Cl2 decompose first order. The half-life is 2300 seconds in an experiment with initial concentration is mole. What is the concentration in mole per dm2 after 4600 seconds?
Uh, B.
Originally it is what you mentioned.
B. 0.5.
Look, original concentration is 1 mole per dm2. Okay. Then after first half life means after 2300 seconds, it will be 0.5 mole per dm2. Then after further 2300 seconds,
So there
which
are two half-lives.
two half lives are there, so it will be 0.25 mole per dm cube. So that's why C will be the right answer. Is it clear?
Yes, sir.
Question 13. Which classes of halogen alkane can react with alkali by mechanism of SN2?
That's A.
A. Because tertiary is always SN1. With secondary, some of the secondary can have SN1, some can have SN2, but for primary it is always SN2, and for tertiary it is always SN1. So all the other options B, C, and D we have tertiary, so it cannot be. That's why A is the right answer. Question 4D. Question 4D. The equation for reaction between bromate and bromide ion in an acid is shown. The rate equation is given when the concentration of all reactant double. The rate will increase by, it's the same question repeated.
Yeah.
What could be the right
So
answer?
16 again. D.
Yeah, so it will be the 16. So you will find that questions are similar and repetition is also there. Question 15. The decomposition of hydrogen peroxide is catalyzed by iodine. The rate equation, so you can clearly see original overall equation and the rate equation. The overall equation does not involve iodine, but the rate equation involve iodine. So what we can say about this?
Should be C, I think.
C or D? Because if you see, according to rate equation, rate is proportional to concentration of hydrogen peroxide 1 molecule, and it is proportional to concentration of iodide, because it's first order with respect to hydrogen peroxide and first order with respect to iodide. So it means that the slow, it cannot be one step because it does not involve the original reactant, all the original reactants, so it is multiple steps. The catalyst does not use up, that's totally wrong. because catalyst is a substance which does not change during a chemical reaction or chemically does not use up. The slowest step is the reaction when one molecule of hydrogen peroxide reacts with one molecule of iodide I.
So we don't have to look at the reaction equation.
Yeah, we don't have to look at reaction equation. We have to check the rate equation, which determine, because rate equation is always for the slowest step, and we have to check what is the order of the substance present in the rate equation, and with reference to that we can work out the correct answer. Is it clear?
Yes, sir.
Question 16. Which of the following sketch shows a reaction with zero order with respect to reactant Q?
That's A.
A. Because the rate is constant, the concentration change. The typical result of rate experiment are shown. The graph is there between ln rate and 1 over t. For the graph, EA is given by how we can get the activation energy. So we have this equation of a straight line. We can compare it, that y is equals to mx plus c. So on y-axis, if we have ln k, on x-axis we have 1 over t. So our gradient will be minus E over r. But we need EA, so it will be mr is equals to minus EA. Or because we need EA, so we can say EA is equals to minus gradient into R. What is the right answer?
C.
C. The rate equation for reaction which carbon disulfide decompose is given. What will be the unit of K? Its first order reactions. What will be the unit of K? Unit of rate is moles per dm cube second, and unit of concentration is moles per dm cube. So what will be the unit of K we solve? This will cancel. So it will be
1 over
second,
second or
1 over
second
second or
inverse.
second inverse. That's why we use the right answer. Question 19. The chemical equation and the rate equation for reaction between nitrogen monoxide and bromine are given. When the concentration of nitrogen monoxide is half and the concentration of bromine is double, the rate, what happened to the rate? So how we can work out according to rate equation? We always check the rate equation, not the overall equation. But in this case, you can see the overall equation is consistent with the rate equation. It is second order with respect to nitrogen monoxide and first order with respect. So the concentration is half. So this is divided by 2. This will be divided by 4. And the concentration is double. This is double. This will also be double because it's first order. So one is divided, multiplied by 2, another one divided by 4. So what is the overall change? It will be 1 by 2, or it will become half of its original value. So C will be the right answer. Is it clear? Question 19.
Sir, how do you do this? Like multiply over divide?
Yeah, because what happened, according to equation, rate is equals to K times the concentration of nitrogen monoxide raised to power 2 and concentration of bromine raised to power 1. They mentioned we halve this concentration. It is second order. So second order, if rate is double, if concentration is double, rate will increase by 4. If concentration is triple, rate will increase by 9. But here what happened? the concentration is half. So if this is divided by 2, then rate should be divided by 4, because it is second order with respect to nitrogen monoxide. So if we have original rate, any value is there, original rate x, that should be divided by 4. And then with respect to bromine, it is first order, so if it is double, then the rate will be double. So
Oh, okay. So 2 over
because
4. Yeah,
so it is
makes sense.
multiplied by 2. So when we solve this, the final answer will be rate by 2. So means the original rate will become half. Which graph shows how the rate constant changes with temperature? A, B, C, or D? Rate constant changes with
It should
temperature.
be A because it's directly proportional.
Actually, because the equation is not like directly proportional, it is ln k is equals to EA over RT plus the constant. So it means it does not have direct relation. It has exponential change. If temperature is double, K will increase with a greater factor. That's why C will be the right answer. Because it's ln K is involved with T, so it means there is an exponential change in K. Is it clear?
So, but according to this equation, shouldn't it be inversely proportional because
No,
it's
what
in the
happened in mathematics, ln, if you remember, when we write, if you have studied this formula, pH is equals to minus log of hydrogen ion concentration. So what actually it means, whenever logarithm is involved, if hydrogen ion concentration is increasing, the pH will decrease. But when there is a negative sign, so what happened, as you can see, we have the formula that log K or ln K. What is the purpose of the ln? The purpose of ln is just to reduce the value. So in logarithm, if it is written negative, like if I say x is equal to ln y, so if, or it is written 1 over ln y. So basically in logarithm, what happened, if one of the quantity is increasing, the other quantity will decrease. So you have this equation, ln k is equals to ea over r into 1 over t, and that is negative, plus the constant c. So what it shows that if we increase the value of ln k, the value of the 1, or if we increase the value of 1 over t, the value of the ln k will decrease. But if we say what is the relation between ln k and t, so it is ln k is equals to 1 over t. So what happened, the value of 1 over t, if value of 1 over t is increasing, the value of ln k is decreasing. And how the value of ln k is decreasing, if we decrease the value of t, because if I take a smaller value of a t, 1 over t will increase, so ln k will decrease. Is it clear?
Yes, sir.
So simple idea, whenever logarithm function is there, because if you have this formula pH is equals to minus log of hydrogen ion concentration, basically it's like pH is equals to 1 over log of hydrogen ion concentration. And then, so if we increase the hydrogen ion concentration, the pH value is decreasing. So 1 over T is decreasing, but T is increasing. So that's why they have an exponential relation, and rate or rate constant are increasing with the temperature. Question 21. propanol react with iodine in an acidic solution as shown in the equation, which is a most appropriate technique to measure the rate of reaction?
D.
So for 21, yeah, it's D, calorimeter. Then which statement is not correct? Which statement is not correct?
Probably the rate, the unit of the rate constant.
It is second order. So when we check which statement is not correct, the overall reaction is second order, that's true. The unit of rate constant, that's also correct, because when you work out the unit of the rate, it is mole per dm cube second, K, mole per dm cube, and mole per dm cube. So this mole per dm cube will cancel with this. So we are left with 1 over second, and mole is there dm cube. Dm cube is divided, other side multiplied, and mole is multiplied, other side will divide, and second. So it will be dm cube, mole inverse, second inverse. That's also true. The rate constant increases with temperature. That's also true. The rate increases 4 times and concentration of propanol and iodine double.
Oh yes, iodine is not even here.
Yeah, iodine is not involved in the rate equation. That's why it is not correct. Part C. The reaction is carried out using a large excess of both propanol and acid. Which of the following shows the change in iodine? Because it is zero order with respect to iodine. So what could be the right answer?
So A.
A, that concentration of iodine change will be there. The slope will be constant, so rate will be constant. 22. Which of the following method would not be suitable for measuring a rate of reaction between methanoic acid and bromine?
C.
So quenching and titrating with acid, yeah, because we don't have acid involved. Then 23, the reaction shows hydrolysis of bromoalkene. The rate equation is given. So it should be a, because rate only involve halogen alkane, so it should be a tertiary halogen alkane. Which of them is a tertiary halogen alkane?
D.
Yeah, that's right. D. 24. Halogen alkane is reacting and the rate equation involve only the halogen alkane. Which of these statement is incorrect? It will rate in only involve halogen alkane.
Uh, should be B.
Yeah, because it should be tertiary, it cannot be primary. And 25, the rate equation for reaction between hydrogen gas and nitrogen monoxide is shown if the concentration of both reaction double. How the
That will be 8. So D.
study will be the right answer. So this was exercise related to rate and order. Today we discuss MCQs. Tomorrow we'll do structure question related to this topic. Any question related to the class?
No, sir.